So up next, we have Kevin Dela Rosa. Kevin has got 14 years of experience in multimodal AI, building audio, visual content into structured data for a lot of use cases. His work has been featured at technical conferences such as CVPR, KubeCon, AWS reInvent, AAAI, ISMIR, and a lot more. Now this is going to be an interesting talk. Imagine making use of AI agent for performing real-time OSINT with the help of a video. So this is going to be a video hunter tool. We'll see a live demo where we'll be able to identify a target logo and relevant context, and then from a random video clip, and then extract OSINT data. So we'll understand how autonomous agents transform overwhelming video data into OSINT insights rapidly and effectively. So this appears to be a very interesting one. I mean, video, AI, OSINT, there's a lot of things together. So please welcome Kevin.
Thanks for the intro. All right, so my name is Kevin, and I'm going to talk about an AI agent I made called Autonomous Video Hunter. Just a quick plug about me. My name is Kevin Dela Rosa. I'm a founder of a startup called Cloudglue, which focuses on agentic systems that see and understand video. And like, as you mentioned, I've worked in a lot of different places doing different vision and speech kind of things at Amazon and Snapchat and a whole lot of other places. And I hope some of my insights are kind of helpful for you guys. So the premise of this talk is that like videos have a lot of information trapped in them, and it kind of makes an interesting target today with the emergence of these new capabilities in AI systems that allow you to like extract that information at rest and target things within them. I mean, there's the obvious like targets like connected cameras that you can find in Shodan, or like satellite imagery, government proceedings. But then there are also things like social posts on TikTok or people posting on Reddit, and from there you can find different people's faces or license plates about cars that people are complaining about, or many different topics that people mention. So being able to kind of reason about these things at scale, I think is interesting, and that's kind of the premise of the video AI hunter. So the autonomous video hunter is a proof of concept system that I built to help people kind of play around with getting multimodal context into their agents or AI systems. Like the, you can kind of think of it similar to something like Claude Code, which is kind of a deep research AI agent, but instead of vibe coding a website, you're kind of vibe coding an intelligence report, I guess, using different like lower level vision and like audio analysis tools. And within this AI agent, I have these different tools, and it'll kind of create a plan of attack based on what you want to target, execute the tools at the right time, and then synthesize like a report about the intelligence that you wanted to gather. Broadly, the architecture for this looks as follows. There's some system that first listens to the videos of interest. This is going to be like the most variable thing in this setup. I'll motivate the demos I have in a few different scenarios. But then once you have the videos of interest, you put them through something that processes the videos so that you can get like general context at rest. You put this context into something that is searchable or queryable essentially, and connect it to a video analysis agent, which will, as I mentioned, kind of orchestrate the different tools to fetch out the interesting bits of information. So with kind of the preamble out of the way, I'll kind of like show a few different examples. So I'll kind of motivate it with one example where suppose you want to, suppose you're like, I don't know, someone in the city of Zurich, and you're interested in knowing when certain celebrities come into your town and like broadly what they're doing, I guess. So if you were kind of doing this manually, you might take a celebrity like Will Smith and kind of like fetch the videos that are coming in as they come in, and you see, okay, Will Smith's not there, Will Smith's not there, not there, not there. But then you find a video that he's in, and you decide to watch it, and actually like extract information from that. So that's kind of the premise of this first demo. So I'll show the different bits of the pipeline that I mentioned to help find Will and see what he's up to. So first bit is a social media intelligence video listener, basically a scraper of TikTok, I guess is what I would categorize that. And for this I used a no-code platform called Gumloop to kind of get that information. So I'll switch over to here. So recording this demo because I wasn't sure how the Wi-Fi would be here. So essentially, with Gumloop you can make interfaces like this, where you enter some input. So the input here is like the city I'm interested in, and then like an email, wherever I want this information to get sent to. And while that kicks off, what will happen is, like under the hood, there's like this workflow that sends this hashtag that I'm interested in to a thing that scrapes TikTok, some number of videos that I'm interested in, the criterion of those videos, some text processing loops essentially to turn it into a nice set of URLs, and then something that actually sends an email notification. You end up getting like a list of videos scraped from TikTok, and you can kind of see like they're all related to Zurich. Cool. And then kind of the next bit, as I mentioned, was like processing this video and putting it into some kind of searchable context store. I don't really have a demo for that, but I have like sample code, and I'll also share sample code at the end of the presentation that you can like play with, around with. But essentially this, what the video processor does is kind of two things. First, it kind of mechanically handles the different frames, and for this POC kind of stores them locally on your computer, and then also runs a vision language model over it that gets a dense description of what is happening in that video. And this is kind of helpful for like ad hoc search or information extraction type tasks. And then kind of the meat of it is this video analysis agent, which essentially uses this framework called LangGraph to kind of pipe things together. So let me show that. So in this example, we have this target face that we're trying to find. And I have a video database with about 50 videos in it from TikTok, from Zurich. And I asked the agent, hey, like, find the videos that are about Zurich, and you know, tell me where this man appears, and broadly, what are they doing in the context of why they're in Zurich. And when you hit enter, they'll make some like LLM calls to come up with a plan of action to kind of determine how to actually do this. They'll then, like, based on its to-dos, execute a series of like computer vision calls to do like face detection on each of the videos of interest that it found, and then kind of write up a report about what this guy was doing, as you can see at the bottom here. Yep. And then I'll show you what that output actually looks like in a larger screen. So yeah, first you have like in Markdown, like the key findings. So like which video did they find it? What timestamp within that video were they talking? What were they doing in Zurich? So you have like the general narrative of what he was doing. So he's like taking a walk because he had an unexpected travel day in Zurich, and you can also get like a breakdown of his emotional state. And then like the frame that was referenced was this one within the video, and it gave me a cropped face of the matching face. So for that, basically like accomplished the mission of understanding what Will was doing in Zurich. And just to kind of like motivate that it's not just about like faces, I guess. You can also do things with arbitrary images like logos or maybe like building facades, those kind of things. So in this demo, I'll show having a target of like Starbucks logo and just generally trying to understand what people are doing when this logo like appears in video streams. So again, kind of similar to the previous demo, you have like a target video, a target image that you want to find. You reference that in chat. You ask like, where does it appear? Give me some aggregate summary about the context in which it appears, and like show me the actual appearances. Again, it makes a plan, executes that plan using different tools, and yeah, writes up a summary about what it saw. Like so. And the output kind of looks like this, where it kind of found the logo in like 4 of the 15 videos I shoved at it. It basically found it on the building facade as well as on cups and like within like, I think it says like a work context, so like employees wearing the logo, basically telling you that they were in customer testimonials or employee demonstrating what they're doing and promotional material. So cool. So now we have an understanding what people are doing with Starbucks logos. Under the hood, there's a few different things going on. So as I mentioned, this is largely like an AI agent. And what I mean there is like, it is like an AI system that uses a large language model to first come up with a plan of what it should do. And once it has its plan, like we orchestrate through different tools that call to lower level like machine learning models. And then we save these things to disk or like some context database, and then get a summary at the end of like that response to whatever the user was interested in. So I'll go over like what's powering a few of the key components. So first, like there's like a general video understanding step, as I mentioned, in the video processor that's powered through an API that my company provides. And essentially what you get is like a dense play-by-play description across different modalities in the video for each scene. So like for each few seconds you get like a visual description of what's happening, an automatic speech transcription of what was said, and as well as like just any text that appears on the screen. And this is kind of like generally helpful information for search intents or like filtering down from like a larger set of videos what to target. Then there's also like a specific targeted extraction that you can configure. I kind of configured it to the different tools of interest exposed in the first version of Autonomous Video Hunter. So namely, at a glance I can tell like how many videos have a logo or have a face, have any speech at all, are set outdoors versus indoors, or have text. And this kind of helps the agent short circuit its orchestration to basically filter out things that are not relevant. Then there's like the process of like generally matching faces to determine like, does this person appear in the video frame? For this, made use of a library called DeepFace, and configured to use a model, I think it's maybe like 4 or 5 year old model called Retina Face, and that detects where within a video the face occurs, and then like VGG Face, which is used to find the key points and compare like, is this actually the same person or not? And I should mention like for this demos, I bias towards like models that can run on a CPU, so you can run this on your laptop instead of calling off to like GPU farms. Also, I mentioned there's like this general image matching component, which you can use to find like if a specific reference image matches one that's found in a target image. So you can use this to analyze logos, find posters of interest, building facades, these kind of things. And this is powered through a library called OpenCV, make use of classic SIFT visual descriptors, which basically turn a video or turn an image frame into a set of 128 dimensional vectors, and then use an algorithm called RANSEC to match, to determine if two images are a good match of each other, essentially. And then lastly, like the other big vision component within this system is a zero-shot object detector. So basically, the purpose of this model is to find within an image where does like an arbitrary concept occur. So for example, in this image of an astronaut, I asked for like, where's a flag, where's the rocket, where's a logo, and you can see like the yellow boxes like show where it is. And for this, use like the open source Hugging Face library, and use a model called ALT v2 with reference to that paper if you're interested in knowing the details of that algorithm. And the thing that kind of glues all the pieces together is this deep agent. So like this is basically, as I mentioned, an AI agent, which does like 4 components. Like it does a planning step, like I said, to kind of plan around what steps should be taken to answer the user's question. Then we have sub-agents or sub-tools that kind of can be used within the processing of this larger orchestration. You have access to a file system or memory to like write things as you encounter them and fetch them later. And then like a system prompt, or basically like instructions that you're giving the AI on like, hey, I want you to do this specific task. And aside from like the larger orchestration that like calls into the different tools, there are like 3 sub-agents that I provide. One that like helps do facial analysis well within a video, one that does visual analysis, and one that does like general content analysis. And as I mentioned, they interact with something that stores memories over time, so that you can fetch like previously analyzed stuff about a video. This is kind of like how the different agents interact within the Autonomous Video Hunter. You have like this main video analysis agent that does kind of general things with the video to get the general context, executes search, compares videos and finds cross-references. Then you have like sub-agents to do the actual facial analysis, to do the video analysis of detecting objects and matching images, and then like the content analysis agent, which determines sentiment and extracts things like temporal information, and all of these write to some investigation markdown file. Cool. And then, so there are different applications you can do aside from those demos I showed. One interesting thing I did was kind of connect a screen recorder to this to get like real-time summarization of what was happening on the screen. So for this sample, basically I rolled my own screen recorder, basically sent like 10 seconds of the screen up to the video processor, which then would index it in a way that the agent can interact with. And then like to kick it up a notch, I connected that to Claude Desktop through a protocol called the Model Context Protocol to allow me to use Claude's AI to do visualizations over the insights that were extracted. So, and then like, I don't know, the 10-second version of what MCP is it's basically a protocol that is used within AI systems to expose different tools or resources to the AI chat application like Claude Desktop. So yeah, as I mentioned, I had the screen recorder. I did this like during a hackathon I was at that was focused on this model context protocol, and just kind of like scrolled through things like Discord to see what people were talking about, and then connected it to the AI interface. And I'll show a demo of what that looks like as well. So with the videos, as the videos are coming in, you can ask questions about like, what are people talking about in this Discord channel? So you get like a summary of that. What are the conversations essentially that are in there? And it's interesting because like it's attending both to the text and like visuals in there. And the reason I exposed it to MCP is that like Claude's actually really good at visualizing things. So it'll write ad hoc little websites to give you visualizations on different aspects of what's interesting in the thing, like what things were mentioned or what types of implementations people are trying to use, what concerns people have about this general protocol as illuminated through their discussions, and what kind of general topics people talked about was also shown here, and like how frequently people were talking about this thing. And then like, I think like everyone kind of has like a knowledge graph kind of visualization when you do this kind of stuff, so I'll show that too, in case people care about that, and you can like stretch the nodes or whatever and see what people are talking about. Cool. And then like, yeah, I imagine motivated people can come up with a lot of different applications of this kind of, here's a bunch of tools that can talk to video, tell me something interesting about it. I can imagine things like monitoring protests, finding out like who's a bad driver, what are influencers talking about, and different government use cases. Yeah, to recap, this was kind of the general architecture of the autonomous video hunter. You have a video listening step that is kind of application dependent. You have some general video processing step that gets like the low-level information for you. You have a context store that allows you to search and fetch things as you execute. And then you have an agent that can orchestrate the actual analysis. I think different challenges come up when you do this. So depending on your budget, like you can use better tools to get higher accuracy, but that comes at the cost of like slower inference typically, or like more expensive things. For the repo that I'm sharing, like I mostly use cheaper things so you can get the idea of what to do. And like, yeah, I think with Autonomous Video Hunter, you can go from like a large corpus of videos to filter out the noise and get like actionable intelligence. Yeah, as I mentioned, these tools like play naturally with deep research style agents, and they're biased towards mostly things that run on a CPU, so for like educational purposes, but you can obviously swap those out with more state-of-the-art things if you have access to GPUs. If you're interested in like learning more, there's a QR code that goes to my link tree, and it has a bunch of links. Well, it has a link for this slide and like the GitHub repo, and I'm pretty easy to find on Twitter. And in case you don't do QR codes, here are also like the actual GitHub repo links that you can also do. Yeah. Thanks for listening to my talk, guys.
Thank you, Kevin. This was an amazing talk. Quite a lot of interesting things to come across. You could then take OSINT and video hunting. That was amazing.